is the cost of that code. What does that cost us in terms of time, developer effort, revisiting, re-engineering? Every line of code has a cost associated with it. A lot of the time we don't think about that, but test-driven development and auto testing is obviously something or other where we're pretty good at on the high level, but we don't necessarily cover all our code. So I had a little bit of homework from last year. The dog didn't eat my homework. I actually did it, which is great. So maybe next year I'll be able to implement something else. And I implemented some code coverage analysis using off-the-shelf tools. Gives us a report that conveniently looks like that. Here's one we prepared earlier. The short version of this, it's the percentage of code that's being executed by our current auto test suite. This is a statically generated version that Peter's put up online for me. It's available at firmware.ardupilot.org/coverage right now. We will be updating it periodically. What it shows to us fundamentally is that right now, ArduPilot has 44% of its code executed. This is lines of code throughout the whole ArduPilot subdirectory. 44% of it is actually executed during a standard auto test, and this is doing all of the plane flying in an entire all the stuff. Copter is slightly better at 49%, so it's nearly hitting half of the code. So that says that the other half of the code is not being tested in any way, shape, or form with our current sort of infrastructure. Yep.
So percentage of source lines, a percentage of compiled source lines. For example, does it include HAL Shibios on CITL?
This is compiled on CITL, and it's just the directories that we're referring to. So anything outside of the ArduPilot directory is excluded. So if you have the HAL Shibios directory down there, we'll see the percentage in there. So
should be 0.
Yes, and it is 0 for a lot of these things. Funnily enough, some directories like AP Proximity has all of its lines of code executed. Do we have AP HAL in there?
No, it looks like it excludes. It's probably compiled lines.
So we can get HAL Shibios in there later if it's interesting.
Well, it's not interesting for CITL. It's distorting the numbers, that's all.
So, but it's interesting because it lets us know that our auto test suite, although it's excellent at giving us a general sense of what's going on, doesn't cover lots of corner cases. It doesn't cover obscure triggers that only occur when you crash. It doesn't cover lots of EKF cases where EKF is given difficult states to handle. It doesn't cover many scenarios that we have code written for. So this is basically giving you guys an awareness of the fact that we need to do better if we want to progress forward and make our code more robust and more resilient. And we want to do that by writing more auto tests, writing more test suites. And Peter's going to be coming up in a second. But I basically just want to come up here and show you guys this. If you haven't seen it, it's great. Let you know that I've done my pledge. Let you know that this is in master right now. Thank you, Peter, for accepting my pull request. And just encourage you to spend a little bit more time on auto tests. That's my time done, and I did it in 3.5 minutes.